Let me give you guys a scenario. The night before, your wife is nagging, and she's yelling, and your kids are just throwing a fit. Wake up the next morning, you have a 9-to-5 job. You come home from work, your kids are in school suspension, and you're grabbing your keys and your laptop from the car, and you're walking up to the door. Then that last part, you drop the keys right when you're about to put them in, and then your head just explodes. So we have a facial recognition security system which will help out with that problem. Stress-free, walk up to the system, scans your face, boom, open the door, open the latches, however many you want, 10 latches, carbon fiber, platinum, whatever makes you feel safe at night. My name is Waleed Solomon. This is Troy, Joe, and Mubin, and Troy will start with the technicals.
Okay, so actually the physical product, we're actually using a basic GPU, but what we're doing is making it a fully automated GPU using the NVIDIA Jetson Nano board. And in a sense, what we're doing is our algorithm is deep learning. So it's a subcategory of machine learning, simple form of artificial intelligence. So what we're doing is we're establishing a neural network, and these neural networks are the facial characteristics of your face, and which is compromised in TensorFlow. Now, TensorFlow is a numerical computation of what this process is allowing the system to do. And then OpenCV is actually the software library that allows us to fully train our product into allowing this. Now, what this helps us and what separates us from everybody else that is on the market right now is that this is a form of AI, so it actually grows with your family. It's for residential use. So as your kids are growing, you don't need to go back and update the picture of your kid. This is actually recognizing the growth of your kid by the facial characteristics. Now, so as we go, we have our person walking up to the door, so the face detection. Now, with TensorFlow, it originates a digital parameter of the face. So we want from the shoulder length above. And the average person has about 100, 150 neural networks, neural nodes in the face. And so that's where it measures the distance between your eyes, your nose, your lips. And so it saves all that, and it gives you the product of that person. So the nodes are actually weighted values. It's not remembering the face, it's remembering the values. And so that's the face detection, the parameters. The face alignment is just justifying the face consistency. So the background are actually data arrays, which is where tensor comes from. And then the nodes are actually what it's reading. And then that brings us to our feature extraction. So once it recognizes those facial features, it extracts the nodes, which gives them a value. And that value is saved to where in the database, which we create, but it will be the home user that creates this, that'll give them the images of the wife, the mom, the kids, and all that. So what it does is it takes the values of what it just confirmed to the database. And what it does is it compares us to. So what it does, it matches both of them, granting access to your house or not to your house. And so some what if scenarios. Let's say we're having a party, and you're tired of some people don't want to come in or whatnot. So what you do is we have a backdoor procedure to where it gives the user's password, and what you're doing is you're still capturing the face to open the door, but it's allowing access for everyone. That's for a large group of parties. Now, unfortunately, we can't connect to the government's database, so you're not going to know if there's a threat in your house. But if you have a picture of the threat, you can confirm that he was in your house. And so ideally, that's the general concept of the difference of our system compared to what's out there now. And August, we have the physical product. September, we wanted to train the deep learning algorithm of the product. And then November, October is our testing procedures, kind of iron out the bugs. And in December, we actually hope to have this running in full throttle. And now I'll open up the floor for questions.
So if you're just going to turn off the system and let everyone in, why do I need that feature? I could just leave it.
Well, that's more for large parties. Let's say you have a kids' t-ball game and you're tired of.
But you said that was the main differentiator.
That's
the
like
existing system. Compared
to the Ring or the products that's out there right now.
But I could just turn that off and then the doors.
Essentially, you could, but then you won't know who comes in. Let's say there was a threat in your house and you got the image. So now you can go back to your database and like, okay, he did come in at 2:54. Whereas if you turn it off, you're not going to be able to compare that.
Yeah. My other comment is, so it seems like you want to use deep learning. So typically that has to have a training set and it has to interact on a lot of images, and you also highlighted like people's faces changing over time.
Right.
So does this mean if my friend comes over all the time and we're always going in the same door, that the door will start opening for him because it's
No.
recognizing him as a person?
Where the
Okay.
user creates a database. So in our sense, we are the users, we are the homeowners. So we are given images of ourselves. And through October to November, that's the training process. So we're training the product to remember us. So the more times we run the system, the more of a memory it has. But in your sense, it does remember your friend. So when you do give him access into the database, all those past captures of your friend will now recognize that because those aren't forgotten. Those are stored in the system. So that would make it easier for that to justify who your friend was.
So there's a
Does that
video.
answer?
There's a video that's there on the web where somebody comes from a dentist and his face is swollen and he just could not enter his house because all he had was image recognition type doors.
No
right?
bypass?
No bypass. I mean, what are you going to think of adding to this so that things like that could be taken into account?
Those are one of
Standing
those.
islands?
Those are one of your uncommon scenarios. But what we could do is we can implement kind of a full password that only you and your family members know. For example, if you have a pencil, you could hold up a pencil and it'll be able to determine the object of what the object is. And so let's say the pencil is what you want your password to be. It's like a universal password that only you and your family know for those scenarios.
Yeah, I would think about those kind of
Is it
intelligent
differentiator?
features. Yeah.
Right. That is a good question, though. So in that case, we would use an object rather than your face, but it'd be important for you to keep that object to your family
Yeah.
for those
Confidential.
reasons.
So you could sell his friends' photos to Facebook
Well,
and make that connection.
yeah, if we're not going to solve burglaries, but we're increasing the home awareness is what we're implementing.
How do you get someone to choose your facial recognition software versus someone coming up there touching the handle and it just open using their fingerprint or something?
There's not going to be handled.
Well, it's going to be your normal door, but the door will remain locked if they're not granted access. So unless you're opening it on the opposite end, you're not going to be able to get in.
I'm talking about how do you compete with that market though? How do you tell them get my facial recognition software and it's better than you using your fingerprint to get in your house?
Well, the fingerprint, if you're real big into germs, you have the germ aspect. But in our sense, it's the AI. We're wanting to throw in the AI aspect. So we're taking away the utilities as far as like the provider where they charge you those unnecessary fees. This is about a $200 top it out is about $200 maximized. So what you're doing is a low cost that promotes coding. So this is for user friendly.
How far off the user has to be, and also what's the accuracy in the darkness and stuff like that?
Because we're in the logistics stage, we're going to say that for testing procedures. As of right now, we can't really give you a confirmed answer. That goes into the testing side, which is September, November.
Folks, let's thank the team.